All right, well, I want to look at our mergeSort program, and I'm just going to restart from where we were in class. So we're going to make a new Java class, and we'll call it merge sorting and public static void main. And this guy going up here, put some comments in. So we're going to look at the merge sort algorithm for an array. So we're going to start an integer array here. Call it array. And I'm just going to use the same one we had in class. So I have the same numbers. And then let's print that out. So we're going to go system.out. Print line. And then we'll use an arrays method of the arrays class to string. And we'll print that array. Run it. Oops. There it is. I didn't want to open this up. Okay, so there's our array. And I don't know what's going on. You keep the coloring, that's okay. Now, what I want to do is I want to write a method that, let's sort of think through the logic here. So we want to split with the merge. What's the merge going to do? Merge is merge and sort. What we're going to do is we're going to split the array. We're going to sort the left half. We're going to sort the right half. And then we're going to merge the two halves. Okay, so let's first create a method called merge. No return value. And what I want to do first is I want to merge the halves. So what we're assuming is that we have our integer array, and we'll call that result. And we have an integer array that is the left half. Let's see. Second. I just want to name consistently with how we did the previous naming. So I'm going to pause for 1 second. Oops, no, my video. Okay, so consistent naming the left side of the array and integer array the right side of the array. And we come in here, I'm going to define two new indices. An integer indice for the left side of the array. And go ahead and set that equal to 0. 0 and an integer indice for the right side of the array, also equaling 0. And now we are going to run a loop through the indices of results. So we're going to say for integer I, starting at 0, going through the length of result. So I is less than result.length. It's the original length of the array. And we're going to go through and we're going to find the smaller element in either the left or the right side and fill it into the result. So it's going to replace what was there with the next smallest item. So we're going to have, as we loop through here, we want to say if. So we want to check if the right indice is already at the end. So we're at the end of the right list. That would mean continue to fill the array with the things from the left list. If that's true, or I'm going to parenthesis, indice on the left is less than the left length. So we haven't finished through the left list. And the element on the left side of the array, the left array, the ith element, and let's move this down so you can see it. Actually, you can still see it. If that is less than the right. And I think I need IL in there, sorry. IR and IL. So what this condition is saying is if I'm out of elements on the right, or I still have elements on the left and they're smaller than the elements on the right, then we're filling in the result with the ith element is going to equal whatever's in the left array at that index on the left of the left array. Otherwise, that means we still have things in the right array, and they're smaller than the next thing in the left array. So we're just going to fill in that result in the ith array spot with the thing in the right array. And then in both cases, we then need to advance the index of that corresponding array. So if we took out of the left array, we need to advance the left array. If we took out of the right array, we need to advance the right index. So this method should merge two halves of arrays into the result. And I want to check that this method works. So how can we check it? We'll go back up to main. So this is what we're writing here is the one that's called merge halves. I want to go back to main. And after we print this out, I want to just go ahead and define a left array. And let's just figure out what would go in the left array. It'd be 1 and 2 and 4. 1, 2, 3, 4, 5, 6, 7. I think it'd just be 1, 2, and 4. And then we want to define a right array, which would be the remaining elements, which would be in order, I'm going to assume that they're sorted 9 and 16. I forgot 5 and 42. 5, 9, 16, and 42. So this is assuming I was able to split the array and sort the left half and sort the right half. Then what would happen? Well, then I would need to call this method merge, sending it the array, the left array, and the right array. And then after that merge was called, we should be able to print our original array, and it should be now in order. Cross our fingers, run it. There it is. It merged the two arrays into a single array that was sorted. Okay, so I now want to think about how we could split this array instead. Where do we want to do that? Let's do that in a method called split for a minute. That seems like a lot of work. So I actually just want to think about, assume that we can split it. We know we can because we did it already, and we can use arrays.copyof and take a copy of the left side, a copy of the right side, and put them in left and right. And then assuming that we can sort the two halves, we now know how to merge the halves. So what I want to do is I want to have a method that does sort of all of these things at once, and we'll call it mergeSort. So I'm going to come down above merge here, and I'm going to have a method called mergeSort. And it is going to accept one integer array, just call it A. We want it to first split this array. And we're going to do that by doing integer array on the left is going to equal arrays dot copy of range. And its parameters are the original array, which is A. And the left side is always going to start at 0. And it's going to go to the length divided by 2. And remember, that will go up 2, but not including the length divided by 2. And then we'll do another one on the right that equals the same thing. But in this case, I'm going to copy and paste. In this case, we will start at a dot length over 2. And we will end up to, but not including a dot length. So that will split the array. And now we're going to do a trick. And what I'd like to do is just call this method mergeSort with that left array, and then call it with the right array. And that is going to mergeSort each array. And then after that's done, we would want to merge those results. By calling the method merge. And we're going to merge A, left, and right. Now, so this is the recursive call to itself. And the problem with it right now is that when I call this mergeSort, it's just going to keep doing that forever. So we need to figure out what the exit is. When do we want to stop merging these together? Well, as long as there's something in the original array, meaning its length is bigger than 1, we'll keep splitting them. So we'll say if a dot length is greater than 1. So meaning there's still something to split. There's more than one element. I'm going to open that up, and then I'm just going to cut all this out and paste it inside there. If my array has more than one element, we're going to split it in half. And then for each of those halves, we're going to call recursively this own method that then, as long as the length is bigger than 1, it splits it in half. As long as the length is bigger than 1, it splits it in half. As soon as we get length that is not bigger than 1, then we merge them and we go back, and everything keeps merging recursively. So let's see what happens. So now back in main, we've done 1, we split, we sort the left, we sort the right, and we merge the two halves. I'm going to delete all this. I'm going to delete all of this. The splitting of the arrays here. And instead of calling merge, I'm going to call mergeSort, just sending the array in. And then we'll print it, we'll send our array in, and we'll print it at the end. You know, if we wanted to, we could put print statements in of left and right and see what's happening. I don't think we need to. Let's run it. There's our merged array. If I change the array, add some numbers to it, I run it again, it still works. Notice I had some repeating numbers in there just to make sure. So that's our recursive merge sort algorithm. I'm going to make it bigger so you can see it if you want to pause to kind of look at all the code together. Let's see if I can fit it on screen here. Comments up. Let's delete that guy. I almost got it all in here. Just to fit it in, I'm going to squeeze this in here. I think that's pretty much everything. So there's the code, and that's our merge sort. And we'll call that a day.